What are the basic set operations?
There are several basic set operations, the most common being the intersection of sets, union of sets, and the complement of sets. The following lists these operations. Note, the first two operations obey the associative and commutative laws, and together they obey the distributive law. Intersection. The intersection of two sets is the set of elements common to the two sets. For example, the intersection of sets A and B is the set of elements common to both A and B. This is usually written as A and B. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the intersection of A and B would be 3, 4. Union. The union of sets is the combining of members of the sets. For example, the union of two sets A and B is the set obtained by combining members of sets A and B. This is usually written as AUB. Thus, if A equals 1, 2, 3, 4, and B equals 3, 4, 5, then the union of A and B would be 1, 2, 3, 4, 5. Complement or complementation. When the set of all elements under consideration must be specified, it is called the universal set. And if the universal set is U equals 1, 2, 3, 4, 5, and A equals 1, 2, 3, then the complement of A, or A, is the set of all elements in the universal set that are not A, or 4, 5. The intersection between a set and its complement is the empty or null set. 0. The union of a set and its complement is the universal set.
How much does air pressure decrease with altitude?
It takes mathematics to figure out how much air pressure decreases with altitude. Close to the surface, and due to the pull of gravity, the air pressure exerted by air molecules is greatest, around 1000 millibars at sea level. From there, it declines quickly with altitude to 500 millibars at around 18,000 feet, 5,500 meters. At 40 miles, 64.37 kilometers, it will be 1/10,000 th of the surface air pressure. This can also be interpreted another way. For altitudes of less than about 3,000 feet, 914.4 meters. The barometric air pressure decreases about 0.01 inches of mercury for each 10 feet, 3 meters of altitude, or a decrease of 1 inch of mercury for each 1,000 foot, 304.8 meters gain in altitude. If millibars are used, it is 1 millibar for every 26.25 foot, 8 meter, altitude gain. That means if a person takes a ride in an elevator, hits the button for the 50th floor and coincidentally has a barometer in his or her pocket, the pressure would fall by approximately 0.5 inch, 1.27 centimeters, during the ascent. This also means that higher altitude cities have major differences in barometric readings. For example, the air pressure in almost mile-high Denver, Colorado, is only 85% that of cities that reside at sea level.
What is supply and demand?
In economics, there are certain factors that control the availability of and the demand for a product. In particular, supply refers to the varying amounts of a good producer's supply at different prices. Simply put, a higher price yields a greater supply. Demand refers to the quantity of a good demanded by consumers at any given price. In general, the law of demand states that demand decreases as the price rises. In an ideal world, the supply and demand would be balanced. Thus, the law of supply and demand predicts that the price level will move toward the point that equalizes the quantities that are supplied and demanded. Economists use charts and graphs to indicate price and quantity, showing the lines of demand and supply, along with where there would be shortages and surpluses. Where the supply and demand curves meet, balance is established. There are also charts that show a shift in demand or supply, resulting in a new supply-demand balance point.
What is an abacus?
An abacus, the plural being either abacuses or abaci, is one of the earliest counting devices. The term comes from a Latin word with origins in the Greek words abax or abakon, meaning tablet or table. These words probably originated with the Semitic word abq, or sand. The device is originally made from wood but now usually including plastic perform arithmetic functions by manually sliding counters, usually beads or discs, on rods or wires. Contrary to popular belief, abaci were not truly calculators in the sense of the word today. They were used only as mechanical aids for counting. The calculations were done inside the user's head, with the abacus helping the person keep track of sums, subtractions, and carrying and borrowing numbers. For more about carrying and borrowing in arithmetic, see Math Basics.
What is the difference between probability and odds?
Probability is usually expressed as a fraction, sometimes as a percentage. For example, if there are 10 pieces of fruit in a jar, 3 apples and 7 oranges, then the probability of taking out an orange is 7/10, or 7 chances of an orange out of a total of 10 chances. On the other hand, odds are expressed as the number of chances for or against, versus the number of chances against, or for. Thus, if there are 3 chances of picking an apple and 7 chances of picking an orange, the odds are 7-3 against you picking an apple. Just reverse this to find the odds in favor, or, in this example, the odds would be 3 to 7 in favor of picking an apple. In order to convert the odds to probability, just add the chances. Thus, if the odds against a horse winning the Kentucky Derby are 4 to 1, that means that out of 5, or 4 plus 1, chances, the horse has 1 chance of winning. That makes the probability of the horse winning 1/5, or 20%.
What are implicit and explicit differential equations?
As seen above, an ordinary differential equation is one involving x, y, 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 and so on. Now add the idea that the order of the highest derivative is n. Thus, if a differential equation of order n has the form f, x, y, 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 n, equals 0, then it is called an implicit differential equation. If it is of the form f, x, y, 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 n 1, equals y, n, it is called an explicit differential equation.
Who was Sir Isaac Newton?
Sir Isaac Newton, 1642 to 1727, was an English mathematician and physicist. Considered by some to be one of the greatest scientists who ever lived. He was credited with inventing differential calculus in 1665 and integral calculus the following year. For more information about calculus, see mathematical analysis. The list of his achievements, mathematical and scientific, does not end there. He is also credited as the discoverer of the general binomial theorem. He worked on infinite series, and he even made advancements in optics and chemistry. Some of Newton's greatest contributions include the development of the law of universal gravitation, rules of planetary orbits, and sundry other astronomical concepts. By 1687, Newton had written one of his most famous books, the Principia or Philosophiae Naturalis Principia Mathematica, the Mathematical Principles of Natural Philosophy, which is often called the greatest scientific book ever written. In it, Newton presents his theories of motion, gravity, and mechanics. Although he had developed calculus earlier, he still used the customary classical geometry to work out physical problems within the book.
What is the difference between descriptive and inferential statistics?
Descriptive statistics is a way to describe the characteristics of a given population by measuring each of its items, then taking a summary of the measurements in various ways. Inferential statistics, as the term implies, makes educated inferences, guesses, about the characteristics of a population by taking and analyzing data from a random sample.
What is a stock market or stock exchange?
The stock market, or stock exchange, is a way of providing companies a means of issuing shares to people who want to invest in various companies. It provides a way of buying and selling those shares. Stocks, or the ownership investment in a corporation, is represented by shares, which are claims on a company's assets and earnings. Common stock means the investor has voting rights in the company. Preferred stock means there are no voting privileges. Owners of preferred stock, however, have first claim not only on the assets and earnings of the company over common stock, but also the dividends are paid first to people who own these shares.
What is the golden ratio?
The golden ratio, also known as extreme and mean ratio, golden section, golden mean, or divine proportion, is a number that has many interesting properties. It is associated with the balance between symmetry and asymmetry used in art and design. Two quantities are said to be in the golden ratio if the whole is to the larger as the larger is to the smaller. Euclid expressed it as, a straight line is said to have been cut in extreme and mean ratio when, as the whole line is to the greater segment, so is the greater to the less. This is seen in the accompanying illustration, in which for two segments A and B, the entire line is to the A segment as A is to the B segment.
Who was responsible for expanding the ideas of predicate calculus?
He German philosopher and mathematician Friedrich Ludwig Gottlob Frege. 1848 to 1925, presented a way to rearrange sentences to make their logic clearer and to show how the sentences relate in various ways in his 1879 treatise, Begriffsschrift, German for Konzeptschrift. Before Frege began his work, formal logic, in the form of propositional or sentential calculus, see above, used such words as and, or, and so on. But the method could not break the sentences down into smaller parts. For example, formal logic could not show how the sentence cats are animals actually entails parts of cats are parts of animals. Frege added words such as all, some, and none, using variables and quantifiers to rearrange the sentences, therefore making them more precise in their meaning. He also developed two of the major qualifier symbols for predicate calculus: the upside down A, V, and the backward E, 3. Frege's work was the foundation for modern logical theory. Even though his work was defective in several respects and was considered awkward to use, by the 1910s and 1920s, Frege's system was modified and streamlined into today's predicate calculus.
What is a common example of mathematical modeling?
One of the most common examples of a mathematical model has to do with the growth of populations, human, animal, or otherwise. In the sciences, this type of mathematical modeling often leads to intelligent hypotheses about the future and past of a population, from a possible population explosion to even an extinction. For more information about the use of mathematical modeling in the sciences, see Math in the Natural Sciences.
How is mathematics used to enable buildings to withstand earthquakes?
It is not usually the quake that kills people, but the collapse of structures. In particular, the horizontal shaking during a quake is mostly responsible for causing building or road damage and collapse. Most structures are designed to carry heavy loads, so they are strong in the vertical direction. Designing structures to withstand the horizontal earthquake shaking can save buildings and lives. There may be other ways to mitigate the amount of structural collapse during quakes. All include a healthy dose of simple and complex mathematics. One expensive way would be to design all buildings to withstand the largest ground shaking an area can expect. This could be done using mathematics familiar to designers and engineers. The math involved analyzes how large quake frequency waves travel through an area. Yet another, more practical, solution might be to design buildings to withstand the specific types of shaking expected in a region. Again, mathematics could be used to determine the frequency at which each building vibrates, or the number of times a building sways per second, versus the potential type of quakes that roll through the area.
What are the parts of right and isosceles triangles?
There are special names for the parts of a right triangle. The hypotenuse is the side opposite the 90-degree angle, the side that will always be the triangle's longest. The shorter sides are called the legs. Similar to the right triangle, the isosceles triangle has specific names for its angles and sides. Congruent, equal, sides are, as with the right triangle, called the legs. The angle formed by these two legs is called the vertex angle, and the base is the side opposite the vertex angle. The two angles that are formed by the base and the legs are called the triangle's base angles.
How is modeling and simulation used in geology?
Like so many other fields of science, mathematical modeling and simulation is used in geology to understand the intricacies of physical events in the past, present, and future. For example, hydrologists, geologists who study water flow above and below the Earth's surface, often use models to simulate the effects of increased groundwater pumping of wells. They may also use a simulation to determine how much water can be presently pumped out of a well, or how much can be pumped out in the future without harm to the environment. Other hydrologists may use modeling to understand the flow of water in a river, bay, or estuary, for example, to determine how the water erodes a shoreline. Still, other researchers may model how snow on a volcanic mountain melts, gathers debris, and potentially flows toward populated areas during an eruption event. For more about modeling and simulation, see Math in Computing.
What is the Heisenberg uncertainty principle?
German physicist Werner Karl Heisenberg, 1901 to 1976, not only helped with the quantum theory of light waves. He also developed the Heisenberg uncertainty principle. This states that it is impossible to determine, at the same time, both the energy and velocity of a particle.
Why is it difficult to win a lottery?
According to one state lottery site, a lottery is a plan that provides for the distribution of money, property, or other reward or benefit to persons selected by chance from among participants, some or all of whom have given a consideration for the chance of being selected. In other words, a person buys a chance at winning a certain sum of money. But in reality, as with many games of chance, the game is not in the participant's favor. With most lotteries, such as a lotto-type lottery, a person has a better chance of being in a car or plane accident or even being hit by lightning than winning. But that doesn't stop many people. One recent statistic shows that, in the United States, an average of more than $96 million is spent on lotteries every day, or more than $35 billion per year. The reason for this dream of winning is simple: it's how this game of chance is perceived. Many people believe that if they just keep the same number, it will eventually be chosen. What they often don't understand when playing a lottery is the idea of replacement. Take a 52-card deck to represent a lottery, with the participant asked to choose a card as the winning card, such as the Queen of Hearts. In the first choice, the King of Diamonds is picked, and not reshuffled back into the deck. After each choice, if the cards are not put back into the deck, eventually, the participant's chances of picking the Queen of Hearts gets better and better. After all, the choices of cards in the deck become less. If one card is left, the participant knows he or she will win. But a regular lottery does not reshuffle the numbers. Instead, lotteries choose from the same group of numbers each week, which makes it even more difficult to win. There may be repetitions in winning numbers, but the odds of winning are the same each time the lottery is played. For example, the odds of winning a recent California Super Lotto game were 1 in 18 million. Thus, if a person bought 50 lottery tickets a week, his or her chances of winning would be once every 6,923 years.
Who developed the idea of a foot in measurement?
Here is quite a mystery about who first developed the foot as a measurement unit. One story, which most scholars believe is a legend, is that a foot was the length of Charlemagne's 742 to 814 foot. Charlemagne, also known as Charles the Great, was king of the Franks and emperor of the Holy Roman Empire. Standing at 6 feet 4 inches tall, he probably had a really big foot. Still another story involves England's King Henry I. 1068 to 1135, in which the length of an arm became important. Henry I ruled that the standard foot would be 1/3 of his 36-inch long arm. This thus became the origin of our standardized unit of 12 inches to a foot. The inch being 1/36 of a yard. According to the Oxford English Dictionary, the first confirmed usage of the word foot as a unit of measurement also occurred during the reign of Henry I. In honor of his arm, he ordered that an iron ulna, the ulna being the longer, inner bone in the forearm, be made. This iron stick represented the master standard yard for the entire kingdom. But around 1324, in response to his subjects' cries for an even more standard measurement, England's King Edward II, 1284 to 1327, changed things again. Recognizing the iron ulna was not universally available, he declared that 3 barley corns, round and dry, make an inch, and that 12 inches, or 36 barley corns, would equal 1 foot. It's interesting to note that even shoe sizes were tied to King Edward II and barley corns. He declared that the difference between one shoe size to the next was the length of 1 barley corn.
What is architecture?
Simply put, architecture is the design of structures, mainly buildings, by architects. But the definition does not end there. An architect not only builds the structures, he or she also takes into consideration the form, symmetry, spaces, and beauty of the building. In order to do this, mathematics is needed to work out such building factors as angles, distances, shapes, and sizes.
What is a mortgage?
A mortgage is a method of using property as security for the repayment of a loan. It is based on a 14th century coinage of a Latin word meaning dead pledge. The interpretation was that the property was dead to the borrower if he defaulted on the debt, and the pledge was dead to the lender after the loan was repaid. For centuries, it's been figured out using mathematics.
What is an ion?
Scientists know that atoms can gain or lose electrons, thus acquiring a negative or positive electrical charge. Determined by the number of protons minus the number of electrons. For example, if there are 4 protons and 6 electrons, the net charge is -2, often called the valence. An ion is an atom or group of atoms that takes on the net electric charge, and can be positive, cation, or negative, anion. Based on the mathematics of losing or gaining electrons, ions can be formed or destroyed. This is one example of where math comes in handy in chemistry.
Why is finite element analysis important to many industries?
Finite element analysis, FEA, is important to various industries, especially those that need to predict failure of a structure, object, or material when under unknown stresses, because it allows designers to understand all of the theoretical stresses within the structure. This cuts manufacturing costs that would occur if a sample of the structure was actually built and tested. FEA uses a complex system of points, nodes, making up a grid called a mesh. The mesh is programmed to contain all the material, properties, and other factors that constitute the structure and determine how it will react to certain load conditions, such as thermal, gravitational, pressure, or point loads. The nodes are then assigned a density throughout the material, all depending on the stress levels anticipated in a certain area. In general, points with more stress, such as corners of a building or contact points on a car frame, will usually have a higher node density than those with little or no stress. As researchers examine the results of the FEA, they learn how the structure responds to the various stresses. In this way, a prototype of the structure won't have to be built until the majority of the theoretical kinks are worked out of the system.
What is combinatorics?
Combinatorics is a branch of mathematics overall, called combinatorial mathematics, that studies the enumeration, combination, and permutation of sets and the mathematical relations that involve these properties. Defined as, enumeration sets can be identified by the enumeration of their elements. In other words, determining, or counting, the set of all solutions to a given problem. Combination is how to count the many different ways elements from a given set can be combined. For example, the two combinations of the 4 set A, B, C, D are A, B, A, C, A, D, B, C, B, D, C, D. Permutation is the rearrangement of elements of a set into a particular order, often in a one-to-one correspondence. The number of permutations of a particularly sized set with n members is written as the factorial n. For example, a set with 4 members would have 4 in first place to 1 in the last place. This would equal 4x3 x2 x1 equals 4, or 24, permutations of 4 members. For more information about factorials, see algebra.
Where did the pound, and its abbreviation, LB, originate?
The origin of the word pound comes from libra pondo, or pound of weight. The common abbreviation for pound, lb, originated from letters in the Latin word libra, or balance scales.
What are some more recent philosophies of mathematical logic?
Mathematical knowledge and logic in the late 20th and early 21st centuries has been greatly impacted by the development of predicate calculus and the digital computer. Out of these ideas, not to mention centuries of mathematics and logic, groundwork come 3 of the latest philosophical doctrines of mathematical thought. Formalism is the idea that mathematics is truly formal, therefore, it is only concerned with the algorithmic manipulation of symbols. In formalism, predicate calculus does not denote predicates or anything else, meaning mathematical objects do not exist at all. This definitely fits into today's world of computers, especially in the field of artificial intelligence. But this philosophy does not take into account human mathematical understanding, not to mention mathematical applications in physics and engineering. Constructivism was a fringe movement at the turn of the 21st century. Constructionists believe that mathematical knowledge is obtained by a series of purely mental constructions, with all mathematical objects existing only in the mind of the mathematician. But constructivism does not take into account the external world. And when it is taken to extremes, it can mean that there is no possibility of communication from one mind to another. This philosophy also runs the risk of rejecting the basic laws of logic. For example, if you have a mathematical problem with a yes or no nature, and the answer is unknown, then neither yes nor no is in the mind of the mathematician. This means that a disjunction is not a legitimate mathematical assumption, and, thus, ideas such as Aristotle's law of the excluded middle, either or, are cast aside. Not many modern mathematicians want to throw out centuries of logic. Set theoretical Platonism sounds as if mathematicians are regressing back to Plato's time. In reality, this philosophy is based on a variant of the Platonic doctrine of recollection, in which we are born possessing all knowledge, and our realization of that knowledge is contingent on our discovery of it. In the set theoretical Platonism, infinite sets exist in a non-material, purely mathematical realm. By extending our intuitive understanding of this realm, we can cope with problems such as those encountered by the Gödel incompleteness theorem. But this philosophy, like the others, has a seemingly infinite number of gaps. Especially the question of how a theory of infinite sets can be applied to a finite world.
Is it possible to simplify logarithms?
Yes, as in algebraic equations, it is possible to simplify logarithms, but in different ways. The following lists some examples: to simplify log 3, x, plus log 3, y, equals log 3, xy. To simplify log 3, 6, log 3, 4, equals log 3, 6/4. To simplify 2 log, x, equals log, x2.
How did Gottfried Wilhelm von Leibniz advance calculating devices?
German mathematician and philosopher Gottfried Wilhelm von Leibniz, 16461716. Not only described the binary number system, a central concept of all modern computers, but also co-invented differential calculus and designed a machine that would perform the 4 basic arithmetic functions. By 1674 he had completed his design and commissioned the building of the Leibniz step drum, or the step reckoner, as he called his machine. The device used a special type of gear named the Leibniz wheel, or step drum. A cylinder with 9 bar-shaped teeth along a length parallel to the cylinder's axis. As the cylinder was rotated with a crank, a 10-toothed wheel would rotate from 0 to 9 positions, depending on its position from the drum. The movements of the various mechanisms would be translated into multiplication or division, depending on what direction the step drum was rotated. Although there were apparently only 2 prototypes of the device, both still exist. Leibniz's design along with Pascal's were the basis for most mechanical calculators in the 18th century. As with most such machines that could not be mass-produced, much less understood by the masses, they were more curiosities for display than machines put to actual use.
What is the millionaire calculator?
The millionaire calculator, invented in 1892 by Otto Steiger, saved many of the problems associated with other devices' multiplication. While earlier machines required several turns of their calculating handle to multiply, the millionaire multiplied a number by a single digit with only one turn of its handle. Its mechanism included a series of brass rods varying in length. These rods executed functions based on the same concept as Napier's bones. For more about Napier's bones, see above. The calculator was a hit, and around 4,700 machines were manufactured between 1899 and 1935. The slide rule was not immediately embraced by scientists, mathematicians, or the public. It took until about 1850, when French artillery officer Victor Meyer-Amédée Mannheim 1831 to 1906, standardized the modern version of the slide rule, adding the movable double-sided cursor that gives the slide rule its familiar appearance. Slide rules were used for many decades as the major calculator for the sciences and mathematics, and ranged in shapes from straight rules to rounded.
What is the identity matrix?
The identity matrix is the n by n matrix that has all ones down the main diagonal and zeros everywhere else. It must also be a square.
Who originated Cartesian coordinates?
Cartesian coordinates are a way of finding the location of a point using distances from perpendicular axes. For more information about coordinates, see geometry and trigonometry. The first steps towards such a coordinate system were suggested by French philosopher, mathematician, and scientist René Descartes, 1596 to 1650, in Latin, Renatus Cartesius. He was the first to publish a work explaining how to use coordinates for finding points in space. Around the same time, Pierre de Fermat developed the same idea independently, see below. Both Descartes' and Fermat's ideas would lead to what is now known as Cartesian coordinates. Descartes is also considered by some to be the founder of analytical geometry. He contributed to the ideas involved in negative roots and exponent notation. Explained the phenomenon of rainbows and the formation of clouds, and even dabbled in psychology.
Why was Gottfried Wilhelm Leibniz important to calculus?
German philosopher and mathematician Baron Gottfried Wilhelm Leibniz 16461716 was a contemporary of Isaac Newton. He is considered by some to be a forgotten mathematician, being overshadowed by Newton. But his contributions to mathematics were just as important. In addition to many other contributions, he, independently of Newton, developed infinitesimal calculus and was first to describe it in print. Because his work on calculus was published 3 years before Isaac Newton's, Leibniz's system of notation was universally adopted, including the notation for an integral. In 1684, he published Nova Methodus pro maximise et minimize, item tangentibus, a work detailing differential calculus and containing the familiar d, or d/dx, notation, along with the rules for calculating the derivatives of powers, products, and quotients.
What are betting odds and how are they determined?
Betting odds are usually written in the form RS, in which R is the chances for and S is the chances against. This can be stated as R to S or chances for to chances against, or S to R or chances against to chances for. But note that odds of 1:1 are said as 1 to 1, not 1 out of 1. Odds are usually calculated as follows: total chances equals chances for plus chances against. Or chances against equals total chances for.
What is Euclidean space?
Euclidean, also seen as Euclidean, space is often called Cartesian space, or more simply, n-space. It is made up of n dimensions and is a set of points, with each point represented by a coordinate of n components. Space with 2 to 3 dimensions and that does not use Einstein's and others' ideas of relativistic physics are considered Euclidean space. In Euclidean space, distance is defined by certain rules. The distance between 2 points is positive unless they are the same points, the distance from points A to B.
What is some of the earliest evidence of keeping time?
No one agrees which culture, first invented timekeeping. Some historians and archaeologists believe that marks on sticks and bones made by ice age hunters in with each hour composed of 60 minutes, and each minute having 60 seconds. It is unknown why the Babylonians chose to divide by 60, also called a base number. Theories range from connections to the number of days in a year, weights and measurements, and even that the base 60 system was somehow easier for them to use. Whatever the explanation, their methods proved to be important to us centuries later. We still use 60 as the basis of our timekeeping system: hours, minutes, seconds. And in our definitions of circular measurements, degrees, minutes, seconds. For more information about the Sumerian counting system, see History of Mathematics.
How long does it take for the sun's light to reach the Earth?
Because the Sun is an average of 93 million miles, 149,598,770 kilometers, from the Earth, and the speed of light is approximately 186,000 miles per second, it is easy to determine the approximate time t it takes for the sun's light to reach the Earth using mathematics. T equals 93 million miles / 186,000 miles per second equals 500 seconds, miles cancel each other out, equals 8 minutes.
What is an aerospace engineer?
Aerospace engineers are directly involved with putting objects from airplanes and the space shuttle to deep spacecraft into the sky and beyond. Using sundry mathematical models and techniques, they install, construct, maintain, and test systems used to launch, diagnose, or track aircraft and space vehicles. They may calibrate test equipment and determine causes of equipment malfunctions. Using computers and communications systems, aerospace engineers often record and interpret test data.
Why is there no Nobel Prize for mathematics?
The Nobel Prizes were established at the bequest of Swedish chemical engineer Alfred Bernhard Nobel. 1833 to 1896, the discoverer of dynamite. First awarded in 1901, the Nobel Prizes honor innovators in the fields of chemistry, physics, physiology, or medicine, literature, and peace. A prize in economics was added in 1969, but there is no award for mathematics. The lack of a mathematics prize has many stories attached, including one that states that Nobel's wife jilted him for Norwegian mathematician Magnus Gostemiddag-Leffler. A notion made less plausible by the fact that Nobel never married. Most historians agree, however, that the reason has to do with Nobel's attitude toward mathematics. He simply did not consider mathematics sufficiently practical. To fill the gap, the Fields Medal of the International Mathematical Congress was established in 1932. It has the equivalent prestige of the Nobel with the limitation that it is only awarded for work done by mathematicians younger than 40 years old, and the monetary value is a mere $15,000 in Canadian dollars, or about $12,000 in US dollars at press time. But mathematics has not been left out of award-winning ceremonies. In 2003, Norway created the Abel Prize for Mathematic Achievement, named after Norwegian mathematician Niels Henrik Abel, 1802 to 1829, who proved that solving fifth-degree algebraic equations, quintics, is impossible. The award gives the winner a prize of 6 million Norwegian kroners, about $935,000 in American currency.
Why do mathematicians and scientists often use scientific notation?
In scientific notation, scientists generally pick the power of 10 that is multiplied by a number between 1 and 10, which makes larger and smaller numbers easier to write and read because they take up less space. For example, in the case of the average distance between Earth and Sun, 9.3 x 107 miles is mathematically much easier to work with than any larger or smaller exponent numbers. The following are several examples of large and small numbers in powers of 10 notation similar to numbers used in scientific notation. Note, numbers that are extremely small in scientific notation will have negative exponents. 748,000 can be represented by 7.48 x 105. 245 can be represented by 2.45 x 102 minus 45. 000 can be represented by minus 4.5 x 104. 0.025 can be represented by 2.5 x 10 to 2 minus 0.0036 can be represented by minus 3.6 x 10 to 3. 0.0000409 can be represented by 4.09 x 10 to 5. 0.000000014 can be represented by 1.9 x 10 to 9.
When was mathematics first used to predict the weather?
One of the first people to use mathematics to predict the weather was English meteorologist Lewis Fry Richardson, 1881 to 1953. In 1922 he proposed the use of differential equations to forecast the weather. An idea published in his book Weather Prediction by Numerical Process. He believed that observations from weather stations would provide data for the initial conditions. From that information, predictions of the weather could be made for several days ahead. But Richardson's methods were extremely tedious and time-consuming. Mainly because they had to be done by hand in the pre-computer age. Thus, most of his calculations came too late to be of any predictive value. Richardson determined that 60,000 people would have to do the calculations in order to predict the next day's weather. But his ideas did lay the foundation for modern weather forecasting.
An even easier way is to what is the chi-square test?
The chi-square test is a way to determine the odds for or against a given deviation from the expected statistical distribution. This somewhat complex statistical test computes the probability that there is no major difference between the expected frequency of an event with the observed frequency of that event, and especially to determine if the set of responses is significantly different from an expected set of responses only because of chance. There are even various ways to perform this type of test, such as the Pearson's chi-square test. Square the numbers first. Note, taking the square root of the variance gives the standard deviation. For example, take the numbers 3, 5, 8, and 9, with a mean of 6.25, the sum of the numbers divided by the total number of numbers. To calculate the variance, determine the deviation of each number from 6.25, 3.25, 1.25, 1.75, 2.75. Square each deviation, 10.5625, 1.5625, 3.0625, 7.5625. Then take the average 22.75/4 equals 5.6875, which is the variance. An easier way to calculate the variance is to square all the numbers first. 9, 25, 64, 81, and determine the mean, 9 plus 25 plus 64 plus 81 divided by 4 equals 44.75. Then subtract the square of the first mean, 6.252 equals 39.0625, or 44.75. 39.0625 equals 5.6875.
What is a magic square?
A magic square is an array of numbers in an n by n square that contains positive integers from 1 to n2 with each number occurring only once. The numbers in the squares are arranged so that the sum in any horizontal, vertical, or main diagonal direction is always the same. This is shown in the following formula: n2 plus 1, / 2. Magic squares are often divided into orders. For example, a 3-order magic square means 3 boxes per row and 3 boxes per column. In reality, magic squares are actually matrices. For more information about a matrix, see algebra. They can be odd order, such as a 3 by 3, or 5 by 5 matrix. Or even order, such as a 4 by 4 or 6 by 6 matrix, magic squares. Perhaps the simplest magic square is the 1 by 1 square, whose only entry is the number 1. Such magic squares have been known for centuries. For example, the Chinese knew about the 3 unique normal squares of order 3. In Chinese literature dating from as early as 2800 BCE, a magic square known as the Lo Shu, or scroll of the river Lo, was invented by Fa Hai, who is thought of as the mythical founder of the Chinese civilization.
Has mathematics been used in art?
Yes, mathematics has been used in art either consciously or not over the centuries. Many of the fine arts deal with trying to comprehend the reality around us. And because both art and math try to explain reality using some concrete or abstract elements, it's easy to see the connection. For example, there are some obvious relationships between art, especially painting, and mathematics. An observer can use geometry to analyze a painting in terms of shapes, such as lines, points, circles, or other geometric shapes. Perspective can also be thought of as a mathematical quality of many realistic paintings, allowing the viewer to see reality, in the case of a painting, in 2 dimensions. And, in a way, Jackson Pollock's method of literally throwing paint on a canvas can be thought of in terms of fractal geometry. Mathematicians may work with quantifying and counting, but most of them will tell you that math is really more than a technical exercise and juggling numbers. Creativity is involved in discovering nuances in certain mathematics, with the mathematician creatively deciding what to concentrate on in order to solve certain complex problems. Just like a picture, mathematical concepts need to be created, invented, and discovered, much like the French painter Claude Monet, and others, invented Impressionism.
When were the first calendars invented?
Although the first crude types of calendars may have appeared some 30,000 years ago, they were based on the movements of the moon and indicated as marks on bones. The Egyptians are given credit for having the first true calendars. Scientists believe that around 4500 BCE the Egyptians needed such a tool to keep track of the Nile River's flooding. From about 4236 BCE, the beginning of the year was chosen as the heliacal rising, when a star is finally seen after being blocked by the sun's light, of the star Sirius, the brightest star in the sky located in the constellation of Canis Major. This occurred, and still occurs, in July, with the Nile flooding shortly after that, which made it a perfect starting point for the Egyptian calendar. The Egyptians divided the calendar into 365 days, but it was not the only calendar they used. There was also one used for planting and growing crops that was dependent on the lunar month.
How are vectors added?
One way to combine vectors is through addition, or composition. This can be done algebraically or graphically. For example, to add the two vectors u-3, 1, and v5, 2. One can add their corresponding components to find the resultant vector r2, 3. One also can graph u and v on a set of coordinate axes, completing the parallelogram formed with u and v as adjacent sides, obtaining r as the diagonal from the common vertex of u and v.
Because it required the who were the Mesopotamians.
The explanation of who the Mesopotamians were is not easy because there are many historians who disagree on how to distinguish Mesopotamians from other cultures and ethnic groups. In most texts, the label Mesopotamian refers to most of the unrelated peoples who used cuneiform, a way of writing numbers, see below, including the Sumerians, Persians, and so on. They are also often referred to as Babylonians, after the city of Babylon, which was the center of many of the surrounding empires that occupied the fertile plain between the Tigris and Euphrates rivers. But this area was also called Mesopotamia. Therefore, the more correct label for these people is probably Mesopotamians. In this text, Mesopotamians will be referred to by their various subdivisions, because each brought new ideas to the numbering systems and, eventually, mathematics. These divisions include the Sumerians, Akkadians, and Babylonians. Memorization of so many signs. The Sumerians also used base 10 like steps of a ladder between the various orders of magnitude. For example, the numbers followed the sequence 1, 60, 600, and 2, 603, and so on. Each one of the iterations had a specific name, making the numbering system extremely complex. No one truly knows why the Sumerians chose such a high base number. Theories range from connections to the number of days in a year, weights and measurements, and even that it was easier to use for their purposes. Today, this numbering system is still visible in the way we tell time, hours, minutes, seconds, and in our definitions of circular measurements, degrees, minutes, seconds.
What is statistical mechanics?
Statistical mechanics applies statistics to the field of mechanics, the motion of particles or objects when subjected to a force. It is used to understand the properties of single atoms and molecules of liquids, solids, gases, even the individual quanta of light that make up electromagnetic radiation, to the bulk properties of everyday materials. Because statistical mechanics mathematically helps to understand the interactions between a large number of microscopic elements, it is used in a wide range of fields. In a way, it is also the opposite of thermodynamics, which approaches the same types of systems from a macroscopic, or large-scale, point of view.
Who was Oliver Heaviside?
English electrical engineer Oliver Heaviside, 1850 to 1925. Was a self-taught genius who made several contributions to the field of electricity and even atmospheric studies. In 1902, Heaviside predicted that there was a conducting layer in the atmosphere that allowed radio waves to follow the Earth's curvature, a layer now named after him. In electrical engineering, Heaviside was best known for operational calculus, a tool for solving linear differential equations with constant coefficients. It was usually applied to brief or fleeting, called transient phenomena, and was very similar to Laplace transform in its calculations. Although Laplace had developed his ideas almost a century before, Heaviside knew nothing of them, because they were not well known during his time. But Heaviside's operational calculus did have its problems, as well as its critics. It was severely limited because of its lack of mathematical theory. This not only limited its applications, but also created many uncertainties and ambiguities in the equations and solutions. Today, operational calculus has been replaced by Laplace transform, especially in fields such as electrical engineering.
What is the heat index?
Our bodies dissipate heat by varying the rate of blood circulation, losing water through the skin and sweat glands, and, as a last resort, by panting when the blood is heated above 98.6 degrees Fahrenheit. 37 degrees centigrade, the average body temperature. Sweating cools the body through evaporation. You can get the same feeling when you put alcohol on your skin. Because as the alcohol evaporates, the skin is cooled. The heat index, high, is an index that combines air temperature and relative humidity to estimate how hot it actually feels. It is based on a mathematical concept called the heat index equation. A long equation that includes the dry air temperature, relative humidity in percent form, and many biometeorological factors too long to list here. The resulting heat index table represents the apparent, or feels like, temperature. For example, if the air temperature is 90 degrees Fahrenheit, with the relative humidity at 60%, it will feel like 100 degrees Fahrenheit.
What are open and closed sets?
Formally, an open set is one in which every element in the set has a neighbor in the set or does not include its boundary. A closed set is one that does include a boundary of a set, or one where some elements have neighbors not in the set.
What are the methods for converting temperatures between the various scales?
He following lists ways to convert from one temperature scale to another using, of course, simple mathematics. Fahrenheit to Celsius, C degree equals, F degree 32/1.8, also seen as, 5/9, F degree 32, Celsius to Fahrenheit, F degree equals. C degree x 1.8, plus 32, also seen as, 9/5, C degree, plus 32 Fahrenheit to Kelvin, K degree equals F degree 32/1.8 plus 273.15 Kelvin to Fahrenheit. F degree equals, K degree 273.15, x 1.8 plus 32 Celsius to Kelvin, K degree equals C degree plus 273.15 Kelvin to Celsius, C degree equals K degree 273.